Hey everyone, here's a quick video on how to solve quadratics using the square root method. Remember, the square root method is really only effective when you have an a term and a c term, but you don't have a b term. In other words, you have something x squared and then a constant being added or subtracted from it, okay? So we're gonna go over two examples, and these examples will help you understand number 3 and number 6 on your Unit 5 test. So the first example is 3x squared minus 147 equals 0. Notice we have an a term and we have a c term, but we don't have a b term in there. So we can solve this directly. We can get x by itself by just doing regular algebra operations. So the first step is to get the x squared by itself. So to do that, we're going to add the 147 to both sides. So we end up with 3x squared equals 147. And then we're going to divide by 3 on both sides. And we end up with x squared equals 49. And then to get rid of that squared, we're going to square root. So we square root both sides. Now, we have to be careful here that when we get our answers, that we're actually going to get two answers, because the square root of 49, what number times itself gives you 49? And most students will say, well, it's 7. That's obvious. But remember, there's another number, -7, because remember, -7 times -7 is positive 49. So when you are square rooting in a function, you're going to end up with two separate answers, in this case 7 and -7. That does not mean 7 times -7 equals 49. It means that x could be 7. So when I plug 7 in, this equation will be true. When I plug -7 in, this equation will still be true. I do not like seeing x equals plus or minus 7. That is a true statement, but that doesn't really help us understand what's happening here. We are getting two distinct separate answers, okay? So that's one example. Let's go ahead and take a look at another example just real fast. This example is going to be 7x squared minus 8 equals 7. Now, the reason that I'm doing a separate example is because the previous one had the answers to be nice, clean, whole numbers. What happens, though, when we end up with some sort of irrational number? So let's go ahead and talk about this. Again, this is a square root method because I have an a term, I have an x squared, and I have constant values. I don't have any just x terms. I can get x by itself. So we're going to add 8 to both sides. We end up with 7x squared equals 15. And then we'll divide by 7. But you'll notice at this point, we get x squared equals 15 over 7. There's a problem with that because 15 over 7 doesn't go in evenly. Now, you could use your calculator and get a decimal answer, but that's not what I'm looking for here. I want to write the answer in simplest radical form. So the next step here, we're just going to keep going. We're going to square root both sides, okay? Remember, the moment you square root, you want to put a plus and a minus there. And I'll talk about separating it as a final answer in a second. But your next line should say x equals plus or minus the square root of 15 over the square root of 7. Okay, we are square rooting the top and the bottom. Now, you should recognize that there's a problem with this because we're not allowed to have a radical in the denominator. That's just not considered proper notation in mathematics. The way we get rid of the denominator, get rid of the radical in the denominator, is to rationalize. So we multiply by rad 7 over rad 7. We multiply by the magic number 1, and we determine the numerator and the denominator, they're the same thing, by whatever the denominator is here, okay? So when we multiply these together, the square root of 15 times the square root of 70 is the square root of 105. And then the square root of 7 times the square root of 7 is just 7. And so that is our answer, but we don't want to write it as plus or minus. Like I said, we want to break it off into two separate answers. So the first answer we'd write as the square root of 105 over 7. And the second answer would be negative square root of 105 over 7. Two distinct, different answers. Yes, they're related, but they're not the same thing, and we don't want to put them together as one answer. Okay, I hope that helps out. I'll talk to you later.